Why did you want to be an astronaut?
Well, I always loved flying. I loved flying in airplanes, and so that was kind of natural to me, and I was always interested in the space program. And so it was one of those things where at first I wanted to get involved in the space program, and I became a flight controller down here at the Johnson Space Center. And I became very interested in the space program. I enjoyed working on it. And then as I transitioned in the Air Force to a flying career as a backseater, as a flight test engineer, I started getting some of the flight experience that I liked. And now I had some space experience and some flying experience. And now I could possibly take seriously the chance of becoming an astronaut. And so I said, well, I'd really better, pursue this like I've always wanted to, because I have a chance now, and I wouldn't feel comfortable with just kind of letting it slip by. And so as I got more experience in the Air Force and the flight test field, and I decided to apply. I applied once to the program and didn't get accepted. I figured, well, if this goal is worth having, it's worth trying hard for. And so I applied again a couple years later, and that time I got in.
Before that, what made you interested in flying and in the space program?
Well, my father was a B-17 pilot during the World War II era, so he was a pilot, and he loved flying, and so he used to take us to air shows. And I think there's something about flying that sometimes runs in the blood, and so that's something that's passed on from my dad to me. And like I say, I really loved flying, and so I was always interested in aviation.
Tell me about the background. Let's start with your hometown. Tell me about your hometown and what it was like growing up there.
Sure. I grew up in San Carlos, California. It's a town of about 30,000 people south of San Francisco. It's a great place to grow up. Pretty normal middle America, playing sports, Little League, football, and I had a great support structure, a wonderful mother and father that really took good care of me and made sure I was going down the right paths for school and everything, and really stressing that. And I had great teachers from grade school, middle school, high school, and then on into college. And like I say, the people there were very supportive, and a very good community, and it was a great place to grow up.
You get to see it during your flights?
Yeah, during my first flight, that was one of my main goals, was I wanted to see my hometown, San Carlos, from space. And so I had to do a little research, because you're going 17,500 miles an hour, so it's not a piece of cake to spot your hometown from 200 miles up. So I looked at some pictures from space of the San Carlos area, and the peninsula of San Francisco Peninsula looks kind of like a thumb, and so I knew if I could find that really easy. So the first thing you see is the coast of California, see the thumb where San Francisco is, and as you get closer, you look for, you need binoculars to do this, or a telephoto lens. But I looked for Highway 280, which goes right up and down the peninsula, and there's a reservoir, a big reservoir on the west side of that. I knew if I found the reservoir, went to the southern tip, looked across the highway, that's San Carlos. And so I got my binoculars out, and we were coming up on the coast of California one time on STS-135, my first flight, and sure enough, I could see the reservoir, and I could see the 280 area, and I could basically navigate my way to San Carlos, and I could see places where I could recognize the San Carlos airport, and I could even follow the streets up to the area where I grew up. And it was just a fantastic thing to be able to see your hometown from space. To think, when I was a little kid, I used to look up and watch the airplanes fly over in my backyard, and here I was flying over at Mach 25 and looking down at my hometown.
Way higher than those airplanes were. Tell me about the path then from San Carlos through your education and your Air Force career that led you here.
Yeah. Well, I went to school at the University of California, Berkeley, and I wanted to be a pilot originally. And so I went through ROTC at Berkeley, and I also got an engineering degree, because I always knew that the flying thing doesn't always work out. Your eyes could go bad or anything. And so I got a mechanical engineering degree from Berkeley, and then graduated from ROTC and went down to pilot training. And they said I had a heart murmur, and they wouldn't let me fly. And so from that point on, I thought, well, hey, I'll never get to fly, and I'll have to do something else. So I took the engineering route in the Air Force, but I heard that while I couldn't be a pilot, I could be a backseater and be a flight test engineer. So I took some various engineering jobs in the Air Force, and I tried to get my resume good so that I could apply to this flight test engineer course at test pilot school. And about 7 years later, I applied to the flight test engineer course, and I got accepted. And I went to get my waiver for that, so I could get for this heart murmur they said I had, so I could fly in the back seat. And when I went to get the waiver, the doctor said, well, you don't have a heart murmur. And so in the 7 years since the pilot training where they wouldn't let me fly, they had gotten better equipment, and they had changed their criteria for what constitutes this heart murmur. So that opened up, obviously, the flight test engineer course. But then, since I no longer had a heart murmur, well, there was a chance I could become an astronaut. So I went through my career as a flight test engineer, and went through the course and worked on the F-16 project out at Edwards for for 4 years, and then had a chance to apply to NASA. And like I say, on the second time I applied, I got in.
When you were thinking that you couldn't be a pilot, were you still had the goal of astronaut?
Well, no. When it looked like my dreams were over there. When I first got out of college, when I was at Williams Air Force Base, they told me I had a heart murmur. I was never going to fly. You know, maybe as a backseater, but I was certainly wouldn't. I figured, okay, I'm never going to become a pilot, and how on earth would I ever become an astronaut? So that was completely out of the question. So if somebody had tapped me on the shoulder and said, "Hey, don't worry, kid, you're going to end up flying in space someday," I would have said, "You got to be kidding me." So it all worked out, but it was quite a different path than I thought it was going to take.
And you've gotten here to a job that where the flying in space part of this job is one that's certainly got its challenges. Well, Rex, what is it that you think we get or learn as a result of flying people in space that makes you feel that that's worth doing?
Well, there's a number of reasons. Number one, we're leaving the planet for the first time. You know, we've been in space for 50 years, but we're still eking our way off Earth and having a permanent presence in space, and that's what the space station is doing. And it's important to keep pushing our boundaries, just like the pioneers in the old days pushed the boundaries and went farther west. And we're learning about our Earth, we're learning about how the human body adapts to space, and we're learning all sorts of ways physical activities and biological processes behave in space that are different. It's an incredible new area to research and to understand, and it's very exciting, and it really is still amazing to both watch the space program and also to be a part of it. And so it's, despite its challenges, it's definitely rewarding, and I consider myself very fortunate to be a part of it in whatever aspect. And once my flying career is done, I still want to be a part of it because I just love being part of the space program.
You're one of the 4 crew members on the final flight of Space Shuttle Atlantis, Rex. Could you give me a summary of the work that's planned for STS-135 and what your jobs are going to be?
Yeah, STS-135 is mainly a resupply mission to the space station. So we're bringing up just tons of supplies, food, clothing, experiments, and then we're bringing back stuff that really only the space shuttle has the capability of doing, large, heavy objects, and just a volume of equipment that no other vehicle can bring back. So my job's first on the way up there is I'm sitting in between the pilot and commander, and we're going to help monitor the systems and deal with any failures we have during the launch sequence. And then we're going to rendezvous with the space station, and I'll be helping them out with the computers and making sure everything's operating properly as we're coming into the space station. Once we get to the space station, the main job is going to be haul all that stuff from the multi-purpose logistics module, which we're carrying up, which holds all the equipment, over to the space station. And then once we get most of that stuff out, bringing down the stuff that we need to bring down. In the middle of all that, we're also going to have a spacewalk where I'm going to be what's called IV, or intervehicular help for the spacewalkers. So I'm going to be reading their checklist. When you're out doing a spacewalk, you can't carry your checklist with you. So all the checklists there, and I'll guide them through the activities, let them know what they got to do next, and kind of choreograph the spacewalk with the help from the Mission Control Center. And then when we've rebirthed the MPLM back into the payload bay, I'll help again on the flight deck with the landing sequence.
There are only 4 of you going up on this mission.
Yes.
Why just 4?
Since we are the last space shuttle mission, we don't have the luxury of having another shuttle that can come up and get us if we have a problem with the space shuttle. So our rescue scenario, if we do have a problem with the space shuttle and we can't bring it back home, is to come back via Soyuz spacecraft. And now we don't have Soyuz up there all that often. They rotate every 6 months. And so in order to come back down, we'd have to cycle down on Soyuzes, and that would take a long time. So the optimal crew size is about 4. Otherwise, people end up staying on the space station for a very extended period of time before they can hitch a ride home.
Even as it is, under this scenario, some of you, were this be to come about, would be staying on the station. Yes. for an extra period of time.
Right.
Describe that scenario. What's the plan then, if we had to bring you guys home?
The plan would basically to kind of change the down sequence of when people would come down. Some of the folks on the space station would stay longer than they anticipated, and then as spots free up for the people who were going to go down at a certain time, we will cycle our crew down one by one, and then they'll also launch Soyuz spacecraft up with just 2 people instead of 3, which leaves a spot for them to come down with one of our crew members. And so we will kind of methodically do that until everybody's rotated down.
But how do you feel about that? Are you comfortable with the idea of coming home on a Soyuz and
Oh, yeah.
maybe getting a couple extra months in space?
Right. Well, coming home to Soyuz doesn't bother me. That's we know that's a very well-proven system that can that has been operating for years and years and does a great job of bringing people to and from space. So that's not a problem. Staying in space for a long time it would really be a privilege, and it would be tough because we haven't been trained on how everything works on the space station. But we can kind of stick together as a four-person team with the shuttle crew because Sandy Magnus, one of our crew members, has been there before. She spent 6 months there, so she can somewhat train us and bring us up to speed without interfering with the regular day-to-day ops in the space station. And we can learn the types of things we can do. And then we all have our own capabilities that we come up with, like Doug knows robotics and stuff. Sandy knows the life in the space station. I have a lot of time with in the EVA area, so we can all kind of help concentrate on those areas and then expand what we know so we can help out on the space station from a day-to-day basis.
Now, you've been to the space station before. In fact, all four of you have been there at least
Yes.
once before, and
Yep.
as you say, Sandy has been there for an extended period of time. Has that experience helped you guys as you've been training for this flight?
Yeah, it does help. The things we're doing are not all that out of the ordinary. It's a great mission. It's going to be exciting. But the individual tasks most people have done before over the period of the space shuttle program. So that's not the real challenge. The real challenge is doing it with just 4 people. So we'll have a lot to do, and we'll each get a chance to do something we haven't done before. So we'll take our base areas of expertise. We'll work on those that we've done before. Like for me being a mission specialist too, I've done that before, which is helpful. There's still always a lot to learn, but I can do that. And working with the EVA crew, that'll be feel real like home for me, which is great. And then I'll expand to do stuff like work on the computers and other stuff I haven't done before, which will be more of a challenge. But other people have done it before, so I'll learn from them, and we'll get everything done.
It's been a while since you've been up to the station.
Yes.
What are you looking forward to of seeing when you get back there?
Well, I think probably what everybody wants to see is the cupola, the big windowed module where you can stick your head out there and see, 360 degrees around you. It's about the closest you can come to doing a spacewalk without putting the spacesuit on. So I'm really looking forward to seeing that. I also haven't seen the Japanese module before, so I'll be interested in going in there and seeing how that looks, and it'll be a really neat experience to see the space station basically in its final configuration. So it'll be quite a treat to see all that.
Yeah, there's a lot more of it than there was the last time.
Yes, there is,
you were there.
and it's amazing to me how big it gets each time I go there. When I was there in 2002 on STS-110, it seemed big at the time, but compared to 122, when we've added Node 2 and the Columbus module, the European laboratory module, it was much bigger, and now it's going to seem just enormous. So it's every time you start the rendezvous to the space station, it just blows your mind just how big this thing is and what an incredible vehicle we put together up in space.
As you said, the biggest priority for this flight is delivering frankly, a shuttle full of
Yep.
supplies to
Yep.
the International Space Station. Tell me about the kind of cargo that you and your crewmates are bringing to orbit.
Well, the main thing we're going to bring is, like we said, supplies. So that is everything from lots of food to clothing, and then we're also going to help them resupply their science. They've got a lot of scientific equipment they need up there, and then just even the space station components, such as global positioning system antennas, rate gyro assemblies, just the various things we need to keep the space station running and keep it livable too.
There is a spacewalk on this flight on flight day 5.
Yes.
But unlike previous shuttle flights, there are station crew members who are going to be the ones going outside to
You
do the
bet.
work. What's the reason for that assignment?
Well, we're one big team with the space shuttle and the space station crew members, and we have to figure out what's the best way to use your resources. And since we are a little bit short-handed on this flight with just 4 people, we figured it was best to let the station crew members do the spacewalk, and we're going to be helping them out, so we're all going to be busy that day. Sandy and Doug will be doing robotics. I'll be doing the checklist from the inside, and Chris will be suiting them up in the airlock. So we're busy, but it works out real well this way. Ron Guerin and Mike Fossum have already done spacewalks together too, so they're a great team to send out there and do our EVA tasks.
All right, well, tell us about what they're going to do this time. What's on that checklist that you're going to be
Sure.
helping them with?
Well, the main thing, the first thing we're going to do is bring back the pump module that failed on the space station. Last summer we had a pump module that failed, and it was a big deal. You had to get that thing replaced and quickly to restore the cooling to the electronics inside the space station. And so that pump module was swapped out. They put a new one in there, but the old one that failed has been sitting up in the space station ever since. And we'd like to bring that home to, number one, find out what happened, because you learn a lot from failures of equipment in space. Say, hey, what's our failure mode? Maybe we didn't expect this, or is it something we expected? And then potentially we could refurbish it and launch it again later on for another spare if we needed to. The second thing, so that we're going to take from the space station and put it in the payload bay of the shuttle. Once we get in the payload bay of the shuttle, Ron and Mike are going to take what's called the robotics refueling module and take this payload and put it onto the space station. And the robotics refueling module, or RRM, is a kind of a test bed of sorts that is going to be used to see how we can remotely service satellites in space. What it's got is it's got a bunch of places where this space station's special purpose dexterous manipulator, or SPDM, can grab onto it, take off caps, try different things that normally we'd have a human spacewalker do, and see if it can be done remotely. For instance, pulling up flaps, cutting MLI or insulation, and taking caps off, or even potentially moving fuel from one vehicle to another. So there's ways to test that with the RRM that we're really excited about. It should tell us a lot about how hard it is to remotely service a satellite in space.
Find out just how dexterous it is.
Exactly. And so it really is the chance to show how well the SPDM can function in space. So it'll be a challenge from the payload standpoint, but also from the robotic standpoint for how we go about doing these tasks. And I'm sure we're going to learn a ton, because there's a lot of neat tools that this spacecraft has that we can test out on the space station to figure out, hey, are there better ways of doing this? Are there better ways of making satellites so that we can refuel them or service them easier in space? And are there better ways robotically to handle situations like this?
Now, to be clear, you're delivering this, but all the work that we've talking about, this test, is not going to occur during your mission.
No, the RRM we will put on the space station where the SPDM, or the robotic arm, can get to it and take care of all these tasks later on when we have more time. We have a very, very compressed timeline. We're trying to do so much in this time with, like I said, with the shorthanded crew, that a lot of the stuff we're going to get set up so people can take care of it later and work when they have more time.
And you've got arm operations that are going to assist in both of these tasks, right?
Yes.
What else is on the timeline besides those two things?
And those are the main tasks for the spacewalk. Now, after we'll have some extra time to do what we call get-ahead tasks, and those are still a little bit in flux. With those kind of change depending on what the highest priority is at the time. So we have a number of tasks that we've trained for, and Ron and Mike have trained for. And when we get closer to flight, we'll decide, okay, these are the highest priorities. These are the ones we're going to want you to do.
No, why waste time practicing for it now when we can use you for what's needed then?
That's right. That's right.
Now, most of the time that you're going to be up there, outside of this spacewalk, all of the crew members are going to be involved in moving over the materials being delivered and bringing stuff back. It's sort of like packing up one house and packing up two houses and moving them across out the same door. Give us a sense of what's involved here, not just in terms of moving items, but knowing where they are and where they're supposed to go, and knowing what goes when. Right.
It's quite a puzzle game, and the very first most important rule is do what Sandy says, because Sandy's lived up there and she's our load master, so she knows where things go, and also how is the best way to rearrange stuff. And so I'll be her assistant, and so we'll figure out ways to make that shell game happen, because before you bring stuff back, obviously you got to make a hole for it. And can you bring all this stuff out of the multi-purpose logistics module before you start bringing stuff back in, or do you bring them back part at a time? So it's kind of one of those puzzle games where we will start bringing stuff in before we've offloaded everything. So it can get confusing. So we have some really talented transfer people on the ground to help us keep it straight, and then we have transfer books to make sure we know what goes where, and then we just do the shell game and try to take care of it all. And invariably there'll be a piece or two that go, okay, did somebody move this? And if we didn't sign for it and say where we moved it to, it can be a problem. So we have to be very dedicated about annotating where things went, who put them where, and all that kind of thing.
I'm wondering whether or not it's, excuse me, all plotted out down to the finest detail, or are you going to have to ad-lib?
We're going to have to ad-lib somewhat, because we'll go grab stuff that's on the space station that we need to put in our return canister, basically, and we'll put it in what we call a bungee jail. It's a bunch of bungees that go across, and we can push them in there at the end there, and they'll kind of float around in there, but they won't go anywhere. So we'll be cramming a bunch of stuff in the bungee jail and taking a bunch of stuff out and take it over to the station. We'll make sure we annotate when stuff goes across, across, but some of the stuff in the bungee jail, you don't know exactly where it is, and you just got to kind of fish it out of there and then put it in its final stow location. So some of it will be inaudible. We'll look and we'll know, hey, this is not working. We've got to get to this before we get to that, or this doesn't fit exactly like we thought it was gonna. And so there will be a lot of audible and going on.
Yeah, delivering is easy, except that you've got to clear space for this stuff to go into.
Right.
It's that's why you've got several days to do it all, right?
Yes, yes. Yep.
When the joint timeline work at the station is all over, the four of you, the shuttle crew members, are going to mark a milestone with the last undocking of a space shuttle from the International Space Station. Is there anything special on the plan for the undocking operation itself as Atlantis wraps up the shuttle's mission at the station?
Well, I think we'll kind of in some way commemorate that activity and just note that this is the last time we're leaving on the space shuttle. And it's, again, that's one of those busy days, so we got a lot of work to do, and we'll make sure we're being very careful about everything we have to do. But I think after we start backing away and get a little farther away where we can let down our guard just a little bit, we'll look back at the space station and just think back on what an amazing thing it is that the space shuttle has done, because without the space shuttle, the space station would not look anything like it does, because the space shuttle is the heavy lifter that got those big pieces up there. And so I think that's when we'll kind of look back and say, wow, you know, it's pretty amazing what's been built up here by a group of 17 different nations all working together, and it's neat that we can be a part of it from the U.S. standpoint to fly and work on the shuttle to make our part happen.
The flyaround is going to be a little bit different than all the previous ones too, right?
Yes, we're looking at flying around, basically kind of around sideways instead of head on. We'll move the station 90 degrees is what we're planning on doing, and then flying all the way around it so we get a different view of the station as we go around. And that's a good way of seeing just what everything on the outside of the space station looks like, because it's always important to document, to shoot a bunch of pictures and to see what the outside of the space station looks like, or any installation flaps coming up, is anything unexpected not looking like it's supposed to look. And so it's kind of hard to do that when you fly the same way around the space station each time. So this time, if with the space station rotated 90 degrees and we fly around it, we have a good view of all sides of the space station.
What do you think you're going to be keeping your eyes peeled for as you do that last fly around and final separation?
I think big picture, just looking at the space station, say, you know, just kind of just taking a step back if I've got a few seconds there, because sometimes when you're so close to these programs, you're so concentrated on your procedures that you don't see the enormity of what you're doing. I heard some of the Apollo guys on one of the specials that was run about that, how they wish they stepped back a little more and appreciated the big picture of, hey, we're sending people to the moon. And so hopefully you'll have a chance for a few seconds to look back on the space station and say, look at what we're building together. We're building the space station, and just really appreciate it just for a few seconds and then get back to work.
When you were assigned to this flight, it was going to be a rescue mission for the last space shuttle mission, and it was going to have flown more than a year ago. Of course, those plans have changed. What was your reaction, Rex, when you realized, I'm going to be on the last space shuttle mission?
Well, it was pretty exciting, because whether I flew on this flight or not, I wanted to somehow be a part of the last mission, whether I was helping in mission control, helping down at the Cape, or helping at one of the abort sites. I just love the space shuttle program, and I just wanted a chance to be a part of the last mission. And to find out I was assigned to it was really tremendously exciting, because I just, like I say, I enjoyed this program so much I want to be there till the last wheel stop. And to think that I'll be riding on the vehicle till the last wheel stop is really an incredible opportunity, and I'm very thankful for.
Is it a special honor or a responsibility?
Yeah, it is a special responsibility, because you want to finish strong. You know, the space shuttle program has been amazing, what it's done, all the great accomplishments, and you just don't want to let that momentum down. And so there is a lot of pressure to do your job right and like I say, to finish strong.
With the end of the program also means a lot of changes are coming at NASA, and that includes some layoffs and shutting down some historic facilities.
Yes.
What is your feeling about the decision that was made to stop flying these vehicles?
Yeah, well, I understand that we need to move on beyond low Earth orbit, and from that point I do understand that we need to develop a vehicle that can get out of low Earth orbit and go on to destinations we want to go on to, you know, past Earth, past to the moon, asteroids, or hopefully one day to Mars. but it's been painful. There's no question about it. It's been very hard watching people we've worked with for years lose their jobs. It's already started, and it's going to continue. And we were just down at the Kennedy Space Center about a week ago, and there were hundreds of people that were losing their jobs the days we were there. And as hard as that was to see, and many people came up and said, "Hey, this is my last day," it was really inspiring to see how upbeat they were about their time on the space program. They really treasured being part of the space program, and it really was inspiring how they understood, hey, they saw this coming, and they still wanted to be a part of it for as long as they could, and they really treasured the time they worked with the space shuttle program. And I take comfort in that, and I know that they've been some great people, and I've enjoyed working with them as much as they've enjoyed working with the space shuttle program.
Each mission comes with its own patch, but it comes from somewhere.
Yes.
Tell us about some of the elements that are in your patch. There's elements of the NASA emblem, and,
right.
and of course the last letter of the Greek alphabet is there
right.
too.
Right. Well, one of the main things we wanted to show with our patch was that it was an incredible team that makes the space shuttle program possible, and so that's why we incorporated part of the NASA emblem. We wanted to show it's the contractors and the NASA civil servants and the whole team that makes it possible. So that's what that symbolizes. And then, of course, the shuttle, a kind of reminiscence almost of the STS-1 patch a little bit. And then, of course, we did want to commemorate the fact this is the last mission, and to do that, we picked the Greek Omega letters, which is the last letter of their alphabet, to kind of commemorate the fact that this is the last mission.
I understand that you guys got some special help in designing the patch too.
Yes, my wife is a graphics designer by trade, and so she was helping us with the patch, and she designed this patch. She actually designed our 110 and 122 patches in my previous mission, so I was happy to have her help. It's a lot of work designing the patch, and she always does a wonderful job. So it was a pleasure to have her on our team to design our patch, and also to incorporate all the ideas that we were giving her and other people were giving her also to arrive at a patch that suitably commemorated the last flight of the space shuttle program. And we all think it turned out nice.
It is nice. It's going to be a part of space shuttle history. Let's talk about history. What do you consider to be some of the most significant moments in space shuttle history?
Well, number one would have to be STS-1. I mean, you just can't get around the fact that was an incredible accomplishment to put two people on a space shuttle that's never flown unmanned, never been tested completely unmanned, and to get them on there and get them home safely was absolutely amazing. And it still boggles my mind that those guys could hear all the stories of how this is all supposed to work. Okay, these white rockets are going to burn for 2 minutes, and they're going to come off, and then the engines are going to burn for another 6.5 minutes, and then the tank's going to come off, and wham, you're in space. And so I go, okay, suit us up, let's go, you know. So it's amazing what the first few crews went through before this thing had been wrung out really well, and before we learned the tremendous lessons that we've learned over the years. They got on board and flew. So that was the first part that just sticks out in my mind, is STS-1 and the initial flights. And then the ability to launch interplanetary probes, you know, to the planets, launch the Hubble Space Telescope, the incredible accomplishments that have come about from the Hubble Space Telescope. Learning more about our universe are just amazing, and that was possible because of the shuttle, getting it up there, and then of course the servicing missions, making sure it was fixed and upgraded over the years. So that was amazing. And then I think the crown jewel of the space shuttle program is just the heavy lift capability of getting the space station components up there and literally building our portion of the space station. It's an amazing accomplishment, what it takes year after year to keep those missions going and to get all the pieces up there, many of which have never fit together before, and to fit them together in space for the first time and for it to all work. And to see a completed space station up there is really a testament to not only ingenuity of all the engineers and scientists and people on the ground who worked on the space station, but also the people who worked on the space shuttle that can make such an incredible, reusable space vehicle to make that happen.
You're going to use Atlantis to wrap up this program. What do you think Atlantis's place is going to be in the history?
Well, I think it's got a great storied past in the part of the space shuttle program. You know, first launching some, like I say, interplanetary probes, Magellan and Galileo, and then doing Hubble repair missions and working on that, and then launching some of the heavy parts of the space station too. Two of the missions I was on, S0, the first portion of the truss, was a very heavy component of the space station, was launched by Atlantis, because Atlantis has the capability of launching those heavy pieces. And on about the rest of the portions of the space station that Atlantis launched. So it's been an incredible vehicle, and it's done a lot of the heavy lifting for the space station program.
If you expand the view beyond just that vehicle, how is the work of the shuttle program going to be remembered?
I think the shuttle program will be remembered for, number one, obviously the first reusable spacecraft. The fact that these vehicles have been flown year after year, mission after mission, and you come back and look at them, it's like, it's amazing. This thing, it looks great. And we were just in Atlantis, looking at some pre-flight items last week, and you just look around and you go, this is amazing. This vehicle is 30 years old, and it looks beautiful. And that's a testament to the care that the people at the Kennedy Space Center prepare it, service it, make sure it's ready to fly, and the care that the people here at the Johnson Space Center around the country that operate the space shuttle make sure that it operates well, and we keep within its operating limits, and take care of it and change out things when need to be changed out and upgrade it when it needs to be upgraded, that it can continue to operate. To have a vehicle that is subjected to the environment that it is in launch and landing for up to 30 years is absolutely amazing.
Any thoughts about what kind of space station we'd have right now were it not for the shuttle?
It'd be a lot smaller. The space shuttle is the heavy lifter, like we say, so it brings up the big components of the space station. And then not only that, the space station would look different, it wouldn't be as big, but also we wouldn't have the science we have without the space shuttle program, because the space shuttle allows us to bring the big payloads, the big large equipment, and science results back down to Earth, which is really the only way we can get those kind of heavy payloads and scientific equipment back down to get the results that we so need.
Well, after STS-135, it's going to be up to spaceships from other nations and perhaps from private industry to get cargo and crews up to this station for the foreseeable future.
Right.
As an American astronaut, how do you feel about the future of the International Space Station?
Well, I think the shuttle has gotten it where it needs to get to be able to move on to the next level of the program. We've gotten the big components up there, so assembly is complete, and now what we need to do is we need to establish the kind of logistics resupply to handle the utilization process, where we're really just doing science on board the space station. So I think we can get there with the commercial entities and the help of our foreign partners. We can get the items up there that we need up there. Getting them back is going to be a little more of a challenge, but I think we'll get there eventually too.
You said that STS-1 was one of the most significant moments in the history of the program. Do you remember where you were when STS-1 took off and how you felt about that flight?
Yeah, I was in college. I was a freshman in college, and I remember in the run-up to the mission thinking that it was amazing, because I'd watched the approach and landing tests on TV, and when they did the landings for the shuttle, and think that was pretty impressive. But to see that whole thing stacked on the pad was incredible, and to hear that it all worked out well, and the launch sequence went well, and they all came home safe. They both came home safe. Was really amazing. So it really got my attention. I remember having a chance to brief some school kids on what the space shuttle was capable of and what it was going to be used for and stuff. And I did that just before the first launch. So it was pretty neat to kind of watch it as it came along, and then to see that it was successful on their first flight.
What's your favorite memory out of the space shuttle era?
Wow, that's probably it's a tough one, because it could be many, many things. And of course the launches and landings that I've been on are high up there. But I think part of it is just the ability that it's given us to contribute to this International Space Station program. Because you get on board on the space station, when you fly up there and you bring a new piece up there, and you see these crews working together, and they're multinational crews, and everybody works together. And we all work together, we work together, we eat together, we laugh about things together, and we're one big team up there, and it's really an amazing example. So the international cooperation that we contribute to the space station via the space shuttle was really pretty impressive. Of course, there's nothing like the rides to orbit, so I think those will stick out highly in my mind.
I wouldn't be surprised. Well, the destinations that we're launching to today, although still in low Earth orbit, are a lot different than where STS-1 was headed 30 years ago when it kicked off this era. Where do you think we're going to go in the next era of human space exploration?
Well, I hope we're going to beyond Earth orbit. It's difficult to get to orbit around the Earth, but it's even harder to get outside of Earth's orbit, to go to places like the Moon, to asteroids, or to Mars. And I hope that's our next step. And I think we'll get there. It's just going to take some time and some dedication on everybody's part. And it's going to take the same ingenuity we see around here that made the space shuttle possible for 30 years. The people who worked in the control center, who processed the vehicle, who designed and conceived the space shuttle. That same kind of ingenuity is still around here. And we'll need to use that to develop the next generation. And the same kind of can-do spirit you saw in the early Mercury, Gemini, and Apollo days. You know, the kids coming out of college today, they've got the same smarts and they've got the same drive. We need to harness that, combine it with the experience we've learned over the last 50 years, and we'll get out of low Earth orbit.